IBS의 개원 10주년을 축하드립니다.
We wish you all the best for your next 10 years. Joyeux anniversaire!
Congratulations on the 10th anniversary of the founding of the Institute for Basic Science.
My heartfelt congratulations and those of the Max Planck Society on the wonderful 10th anniversary.
앞으로도 IBS가 세계적인 기초과학 연구기관으로 지속 성장할 수 있도록 관심과 애정을 가지고 응원하겠습니다.
Hello everyone. Welcome to the IBS Global Summit. My name is Myung Cha, and I will be your MC for this special occasion. I'm a chief investigator at IBS and associate professor at KAIST. Today we will envision the future by discussing the role and responsibility of basic science institutes during and after the pandemic. Our summit is full of insightful presentations and unique perspectives by our esteemed speakers. There will be a Q&A session and a panel discussion to satisfy your curiosity. So we will be accepting both offline and online questions. For our audience here, you can raise your hand during our Q&A session. For our online participants, you may submit your question anytime in the chat box. And now it is my honor to introduce our world-renowned panelists. Please join me in welcoming President Antoine Petit of CNRS in France. And Executive Director Shigeo Koyasu of RIKEN in Japan. And President Martin Stratmann of Max Planck Society in Germany. And President No Do-young of IBS in Korea. We are so grateful that all of you are here for this global summit and for celebrating the 10th year journey of IBS. And also with us are students, researchers, and members of the general public. We can see many of you on the Zoom and YouTube connecting to this talk. Thank you so much. We are grateful and we are delighted to have you. So now let's begin our summit with our very first speaker. Good morning, President Petit.
Hello.
Thank you for joining us from France. Please begin when you're ready.
Okay, thank you very much. So, dear presidents, dear colleagues and partners, on behalf of CNRS, I am very glad and honored to be taking part of this summit, and I would like to start by extending my warmest congratulations to IBS for your 10th anniversary. Establishing a large research institution at the best international level in a short period of time was quite a challenge, and IBS could achieve it. Once again, congratulations, and if you allow me to speak French, joyeux anniversaire. CNRS and IBS have been working closely for the past 10 years in all fields of research, most notably in physics, chemistry, and mathematics. We signed our first international agreement in 2013, and I had the pleasure to come to Korea in 2018 to renew our agreement with the former president of IBS, Professor Kim. And I will just give you one figure to present our partnerships. In 10 years of fruitful collaboration, CNRS and IBS researchers have jointly published more than 250 papers. The partnerships between CNRS and IBS is based on the complementary of our researchers on various projects. But more than that, our organizations share a common objective and interest in conducting excellent basic research for the benefit of society. This takes me to the proposed topic of the discussion about the role and responsibility of basic science institutes in the post-pandemic era. By the way, I would like to thank IBS for the choice of topic. Indeed, this is a question that lies at the heart of all of our actions as an institution. And I believe that the COVID-19 has even strengthened our viewpoint on the need for multidisciplinary, open research in order to adapt and respond to new yet unknown challenges. Conducting research on COVID-19, of course, implied medical research for treatments and vaccines, and overall research to understand the virus. CNRS has taken its share on many fields, working jointly with partnering French institutions like INSERM or Institut Pasteur, but also with European and international partners. But if you look at the true role and added value of our organization, I would say that CNRS has participated to pave the ground for all the research deployed in COVID-19, like all other major basic research institutions across the world. This research actually started decades ago and runs from messenger RNA. Let me recall you that messenger RNA has been discovered by Jacob and Monod in 1961, which is 60 years ago. And this shows clearly the importance of basic research and the fact that the impact of basic research can stand on a long term. And also this research runs to deep learning on bioinformatics that helped to understand the virus. But besides medical research, the COVID-19 impacts on our society are so large that they'll imply research in all fields of science, mathematics for the models, data science, of course, for the treatment of data, but also humanities and social science in order to understand the spread of the pandemic, just to give some examples. And I think that that's very important, is that on a subject like COVID-19, all the disciplines are in fact concerned and can bring something to understand and to treat the crisis. And overall, in concrete and sometimes tragic ways, this has shown to the majority of our society how vital science was. Another important lesson we should keep in mind regards the role of science within society. Whatever the research, we have seen more than ever that transmitting knowledge to the society has proved crucial. This is especially true in a pandemic that has by essence so many social implications. As research institution, we have been at the center of the attention from the people, expecting solutions and explanation in a time of uncertainty. Sometimes this may have blurred the role between scientists and politicians who insisted on relying on science for political decisions. We have to set clearly the distinction between the two roles. Scientists are there to give some advices, but not to decide, and politicians have to do their job, which is to decide. And that's very important, that we have to provide the best tool to explain and transfer knowledge continuously, but the final decision is not ours. And to go on with this, I think this pandemic also showed to all our researchers how vital it is to us to help to convince the society of the benefits of science. Of course, a lot of our colleagues have always been involved in popularizing science amongst a wide public, and they haven't waited for the pandemic to do so. But if you look back at the questions and sometimes unfounded doubts about vaccines, for example, you realize that in many ways, conducting research is simply useless if this is done outside society. Even the best vaccine can only be efficient if widely accepted by the population. And on the other side, many people realize concretely what international competition means. You need to be able to develop the best research in a very competitive background. Otherwise, it would just as useless. And it is now clear to everybody that excellent science is only meaningful at a worldwide level, calling for more international cooperations.
국제적인 협력이 거느되고
And competitions are in fact two faces of the same coin. As a conclusion, I would say it is clear to most of us that strong support of basic science is key in any advanced society. Now, how can we meet up with these expectations and objectives? This comes to very concrete example, and I believe the coming discussion and sharing of points of view and best practices will be very useful to all of us. So thank you once again to our IBS for gathering us today.
Okay. President Petit, thank you so much for sharing your insights. I really look forward to discussing what you have said during the panel discussion. So next, we will hear from RIKEN. President Matsumoto Hiroshi was scheduled to be with us, but he's receiving an award today. In his place is Executive Director Shigeo Koyasu. So Executive Director Shigeo Koyasu, good evening. Thank you so much for joining us from Japan. Please begin when you're ready.
Thank you very much. I have to apologize that President Matsumoto is not here. He is actually invited to the Imperial Palace, therefore he cannot come here. But first of all, dear presidents, I'd like to congratulate the 10th anniversary of IBS. And we've been collaborating with IBS, and we just renewed our agreement last year. So I hope we can continue to contribute our relationship. So let me share my slide to introduce you some of our initiatives toward the post-pandemic era. So we experienced a lot of troubles starting from last year. So at RIKEN, we set up the crisis management headquarters in February last year, and made some basic policies regarding the new strain of coronavirus, which is SARS-CoV-2. Then in March, we set up the special measures and ICT environment, and so on and so on. And in April, our government called the state of emergency. So we ordered all RIKEN work from home orders, except those who are working on COVID-19. And that lasted for 2 months. And then during the May, we set up some gradual resumption plan to restart the scientific activities. Then gradually from June, we opened up the scientific activities together with a strong measure for the COVID-19 prevention. And we also published the RIKEN's COVID-19 prevention manual in May, and then frequently revised, and we last updated April this year. So basically, what we've done is the thorough implementation of COVID-19 preventive measure, and at the same time maintain our high quality research activities, even during the state of emergency. And the President Matsumoto declared the importance of the basic science to contribute to the society. So even we didn't get any special budget from the government, but we used our own budget to fight against the COVID-19 problems. And so using the President's discretionary fund, we started a lot of COVID-19 studies. What we did was sort of unusual. We usually value the originality and to compete with other scientists, but this time we called the weekend researchers that any ideas, if it is very common idea, that's fine. If we can contribute to the COVID-19 problems, any proposal is welcome. So we funded a lot of proposals from the region, and then started some researches. And also we put the research infrastructure like supercomputer and synchrotron facility to other researchers in Japan to solve the problems. And also we started developing the more effective diagnosis kit, and we published the data before the publication, just for that people can use the data for effective therapies and drug design and so on. So we put the using the leading edge facilities like synchrotron facilities and supercomputers, and then we started various researches last year to now. So basically we received a lot of proposals on the various level of researches, starting from the COVID-19 itself to pathogenesis of the pathologies to the genome analysis and so on. So this time I just introduce you to a couple of the examples. One is the supercomputer Fugaku, and the other one is the new detection kit. So luckily, we are new supercomputer Fugaku, and one earns quadruple crown for third consecutive time. And so let me introduce a couple of examples. One is the molecular dynamics of the spike protein of SARS-CoV-2, and then we immediately published these data on the internet so that people can use those data for the designing drugs or antibodies. The other one is the digital simulation animation to analyze how the coronavirus is transmitted by droplets, and that actually helped to design the classroom and compute, the preventive measure during the commuter train and so on. And the other researcher developed a very accurate and rapid detection system of coronavirus, in which he can actually detect this single RNA molecule within 3 minutes in a very small wells. And now it actually exceeded the detection level more than PCRs, and then it is very tough with any contamination. So we actually try to send out to the society in collaboration with the company right now. And in the end, so what impact we got the impact from COVID-19. So basically, it changes the environment surrounding global research activities, which blocks the human, global brain circulation, and a lot of problems, and then impact on the investment on the STI and R&D. But on the other hand, it accelerated the open science by sharing all the data immediately after we obtain. Also, we realized the social cohesion with or post COVID-19 pandemic era, because we are, what is the expectation of the people for science and technology? We have to contribute to the change in the lifestyle and of the reform of the medical system and countermeasures for infectious diseases. And it is really important that prompt dissemination of accurate and comprehensive information from scientific institutes to the public. So those are the what we have encountered. And thank you very much for your attention.
Okay. Thank you very much, Executive Director. It's really impressive to hear about the open science momentum, and it's really great to hear that. So our third speaker is President of Max Planck Society, Martin Stratmann. President, if you're ready, well, first of all, thank you for joining us from Germany, and when you're ready, please begin.
Yeah, I hope that you all can understand me. Thank you very much for the invitation. Thank you, Professor No. Thank you to all the panelists, my dear fellow colleagues, and hello also to everyone sitting in front of the screens. I'm honored to be here with you, even this is virtually today. Well, first of all, I also have to congratulate IBS for its 10th anniversary. I'm proud to state that we have a very long-lasting relation between the Max Planck Society and many research organizations in Korea, in particular also IBS, and I think we just extended also our contract between the IBS and the Max Planck Society. So my warm-hearted congratulations again. I thought I'd give you a brief overview on the situation, how we see it today in Germany, and I wanted also to give you a brief summary on how we have managed, let me say, the COVID crisis within the Max Planck Society. First of all, the general situation in Germany. Germany had, as many of us, a lockdown in the first wave. That was the end of March 2020 for several weeks. We had a second, larger and longer lockdown for more or less 4 months in November last year. And also Germany in general came through the pandemic quite well. We are now seeing a massive pandemic of the not vaccinated inhabitants of Germany. In general, we have now 75% or so of those above 18 are fully vaccinated. Less than half of the ones below 18 are vaccinated, and kids below 12 have not approved a vaccine, have no approved vaccine today, which is available to them. So there are quite many people still in Germany not being vaccinated, which is part of the problem we face today. In Germany's federal structure had made some things easier. We have a very delocalized manner of organizing the country, but some things indeed have been also much more complicated. And in fact, the central government in Germany does not always have a say in health issues that's being dealt with on a local level. What is very positive from the beginning on, we had a very close contact between science and also the Max Planck Society and the government, in particular Chancellor Merkel. Probably this was triggered by the science background of Chancellor Merkel, and she invited many times scientists, high-ranking scientists, even to cabinet meetings when they dealt with the corona issue. Now, for the Max Planck Society in the lockdown months and during summer, we had to reduce our operations on site to a minimum. So many people were working, as in all organizations, I guess, at home. We also, and that was, I think, a positive signal, Max Planck is very decentralized. So we have 80 institutes spread over Germany. And so many institutes could just deal with the local boundary conditions, the local rules, and could act very flexible on the given demands. We had, of course, a central crisis team, which was also supported by decentralized crisis teams at all of our institutes. Many instruments, by the way, it was interesting to see this could be operated from home. We had a remote mode of operation of many instruments, even microscopy, for example, so that we switched very rapidly from presence mode to a kind of remote mode quite successfully. What is a problem, I have to say, is the situation of young scientists in the Max Planck Society, and that's probably true for all of our organizations. You have to know that the Max Planck Society hosts many people from abroad. Nearly 2/3 of our directors are being hired outside Germany. 80% of our postdocs are non-Germans, and more than 50% of our PhD students have a non-German origin. And for them, let me say, to live in Germany in times of the pandemic was, of course, a problem, also a social problem. So many people, in fact, have also psychological problems, which we had to deal with. And that was probably one of our greatest effort to make sure that still people feel well during these times where they more or less have been living on themselves and could not operate in a living institute. Now, a few words on the science, which we have been doing, and I think that's very much the same as what we had heard before. We have more or less 3 sections which had to deal with the pandemic. The biomedical section, and I have to say that in general, the Max Planck Society does not operate in the field of medicine. So, for example, we do not operate hospitals on our own. And so our research is more or less focused on molecular mechanisms of, for example, virus-host interactions, structure of viruses, membranes, etc. The most promising result I can say from the biomedical section is a drug development to fight COVID, which is based on nanobodies which originate from alpacas. It is still a very promising topic, surprisingly successful, I have to say. Very effective in fighting the virus, and this is just currently in clinical trials. That's probably the most forward-looking study we have done in the biomedical section. The chemistry and physical section was extremely active in modeling the spread of the coronavirus in general. We have had many publications in Science, Nature, Lancet, etc. on very detailed physical models on how the pandemic would spread in Germany, and that was also being taken very serious in our discussions with the Parliament, with the government, with the Chancellor. Many of the legislative issues which have been issued in Germany last year were based on these kind of calculations and modeling. The humanities section was very much focused on the social and also political consequences of the corona crisis, in particular also the economic consequence, which we still feel in Europe in particular. Now, my last words on the international collaboration. I think the international cooperation has been never as intense as it has been, let me say, during the corona crisis. As has been stated by my colleagues before, I think all the results have been shared by the major research organizations among the world. So people have immediately exchanged the data on the DNA, on the RNA, on the structure of the proteins, on the membranes, etc., etc., etc. So there is a really intense collaboration going on worldwide to fight this crisis, and I think that is a very positive statement I can say. We also learned from the crisis that working under remote conditions is not that bad at all. So we had many meetings, virtual meetings. We have continued to hire directors for our research institutes from all over the world, even by remote and virtual meetings. So we also learned, let me say, how to use modern technology and to be much more effective than we had been before. And I think that has changed our life totally in the Max Planck Society, and that will not disappear in the years to come. So what I can say is that there is a change in operation, which we all can see, and that change in operation will stay. I'm sure for this. Nevertheless, I think the main problem is that our young scientists have suffered and still are suffering and probably will suffer. We are missing major conferences. We are missing that those people have a chance to meet others. We are missing the possibility for them to look out after the PhD for a postdoc in let me say, remote institutions. And I think we all have to make sure that this is not a lost generation, that not a number that people during these times really have no chance to have to get a promotion in science. I think that's very important for all of us to make sure that we keep conferences going, that we also look out for personal exchange, that we make sure that these young scientists have a chance, let me say, to get promotion in the years to come. And I think that is probably all of our duty in the years to come. Otherwise, I'm afraid that these people will have a very hard time in the upcoming years, let me say, to have a science career on their own in a society, in a science society, which needs personal contacts, which needs exchange, which needs conferences, etc. So that's more or less my view on the pandemic. I think the pandemic is not gone. We are still in it, in Germany at least. I think we'll have a hard winter ahead of us. The worst situation, and I didn't expect this honestly, is that many people in Germany, but I think all over Europe, are afraid of vaccination. And in Germany, it's more or less 1/3. And the question is, why the hell are they so afraid of vaccination, as we can prove by huge statistics that the vaccines are pretty safe. And I think this is one of the questions we have to ask ourselves. Why is it that people do not trust the science? Why people do not trust our scientific conclusions? What is the threat they feel? And why is behavior so irrational? As we can see this, I think, in many countries in Europe today. In the US, I think it's even worse. And that, of course, is one of the problems we have to face in the upcoming years. So thank you for your attention.
Okay. President Struckman, thank you so much for sharing your experience and your sincere thoughts for the young scientists. Our final speaker is IBS President No Do-young. Please welcome him to the stage.
First of all, I would like to thank you to President Petit and Director Kuyas and President Stratman to sharing your precious time for our IBS 10th year anniversary. And as we benchmark Max Planck Society and RIKEN and CNRS, it is great pleasure to have a global summit with the president of this world-leading institute. I would like to introduce IBS a little bit, and then our achievement and prospect in regard to the pandemic. So this is my presentation's content. And first, I will briefly introduce IBS. I think everybody knows about IBS. Simply, IBS is Korea's leading institute for basic science research. It's established in 2011, November. So we are facing our 10th anniversary next week. And the justification of IBS was this. As Korea joins the club of the developed nations, this national science strategy has changed from being fast follower to first mover. So with this, we set up the vision. We make discoveries for humanity and society. And this vision is getting more attention because now we have a lot of problem with the societal problem with the COVID pandemic. The backbone of IBS is the research centers, so that IBS conduct research on fundamental principles of universe and matter and life. So it includes basically every aspect of the natural science. And we have 30 research centers, so that it's like a department at Max Planck Institute. And if you put 3 or 4 research centers together, that may constitute an institute like Max Planck Institute. And we have one research institute, which is started this year, which I will explain it. And we are building this heavy ion accelerator facility nearby the headquarters. So our research centers are scattered through South Korea. And you can see that there are many centers, so-called extramural centers, centered at prominent universities in Korea, mainly focused in the Seoul area. And then we also have so-called Science and Technology Institute in Korea, which is supported by the Ministry of Science. And we have those KAIST, postdoc, UNIST, GIST. These special universities are focused on research. So we are setting up centers there, and we call them as campus centers. Last, we have at Daejeon, at the headquarters, we have 9 centers and 1 institute, and we are building heavy ion accelerator nearby. So that this structure is very similar to probably your structure, which is scattered throughout the nation. And if you look at it, our centers are in physics, biology, chemistry, and earth science and mathematics, and interdisciplinary science. So we are just starting up, and we operated only for 10 years, and we met this crisis, pandemic. So we are not quite ready for that, but we did whatever we can do with this time constraint. Our research center, you can see this is the picture of the headquarters. And we are building our campus labs, and also each universities hosting these extramural centers, they are supporting our IBS with their research buildings. So that will help us very much to operate these research centers. Then let me discuss about this pandemic and changes in the research environment. As I think this is all shared by many nations, the economy is shrinking, and we need a lot of place for these emergency stimulus packages. And also, as we worry about that, travel is limited, and scientists cannot gather together. And in governmental decision, policymakers are changing in R&D environment because we are facing this unhistoric pandemic situation. And lastly, as President Stratman worried about it, there's a lot of spread of misinformation and fake news on these viruses, so that may prevent people from getting vaccinated. So all this impact us researchers, and we have a so-called negative impact on governmental funding on basic research because there are much more places, emergent places to spend money. Also, this is most important difficulties we are having is we cannot hire easily these international researchers, and we cannot perform international collaborative research. So that is especially bad for young scientists, as President Stratman worried about it. Okay, and this focus is changing to infectious disease, and then also this vaccine development. And lastly, we need to communicate with the public so that we can transfer scientific information to the public. So what Korea did, Korea firstly, we were very successful in the initial response to the pandemic. And as reported, that this coronavirus testing equipment, testing kit, are very well developed in Korea, and then it is exported to many countries. Also, we did very well for the prevention measure of pandemic, so that for example, IBS was never closed. Our lab was always operational for during last 2 years, although there was some prevention measures, but the lab was open. So that was that indicated our prevention measure was rather successful. But Korea in general has a low capacity in research to develop this vaccine and antiviral drugs. So that caused recent problems inside Korea. Although many people wanted to get vaccinated, the vaccine was not available in the early part of 2021. So that was kind of trouble in Korea. The government increased the budget very much to respond to these infectious diseases. Also, because we are lacking research institute that can act on these infectious diseases, Korea established 2 institutes. One is National Institute of Infectious Diseases, that is under the Ministry of Public Health and Environment. That is to drive the vaccine and therapeutics development that is immediately needed in Korea. We also established the Korea Virus Research Institute under IBS. This is for long-term or mid-term basic research in virology. And that was the missing part of Korea, and then we studied it very quick, although it's rather small scale. Okay, what IBS did during pandemic, I was impressed by RIKEN's activities month by month on response to the pandemic. What IBS did, IBS researchers, although we didn't have a really dedicated centers for infectious disease, we had many centers related to biology and immunization, and so those areas. So especially the Center for RNA Research, led by Neri Kim, they at the early part of this pandemic, they presented the high-resolution genetic map of the SARS-CoV-2, and this provided to the scientists in the world the information on this COVID viruses, and it was published in Cell. Also, recently, Director Ko at Center for Vascular Research, he uncovered the process involved in the early stage of COVID-19 infection. And this is the picture, and then basically it's nasal respiratory epithelium. There's a spread of this coronavirus is starting from our nose part. And also for the testing, because the usual testing kit involves a big, large-scale equipment, and it takes time. So our Center for Nanomedicine developed nano PCR for accurate COVID-19 testing in short time. This was done in the early part of last year, and that they used the nanoparticles, and then they used magnet, and also using this surface plasmonic effect to heat up the nanoparticle very quick, and to amplify this PCR happens in a very short time. Okay, another part is that we wanted really to share this scientific knowledge with the public, so that our directors of the centers get together and then wrote the fact and scientific thinking opinions on coronaviruses, and then we published this one book which is called Corona Science, and this became one of the best-selling book in science communicator in science community, and then it got a year award 2020. And this year we are publishing. We just published a second series on this book called From Pandemic to Endemic. So these two books are published to foster the public communication on this important viruses. Okay, the last we established, as I talked before, we established so-called Korea Virus Research Institute, because there was no research institute in Korea which is dedicated to the basic part of the virus research. So that we quickly established this, and we discussed with the government, and then we started this Virus Research Institute in July this year. And then we are now setting up, we are gathering people, and then setting up the equipment, and preparing the buildings for this basic research. And we wanted to enhance the basic research capability to contribute national health security strategy against these viral diseases. Okay, post-pandemic area, as this Peter Dorothy Nobel laureate said, we are facing new normal. This is completely different from before, and this is not the end. This COVID-19, as he said, this is just a training session. We will face many this kind of viruses or other crises, and now we need to prepare for this new normal. So because this will come more often to us, so that Professor Furman, as he said, we shouldn't spare any expenses on health or testing or hospital system, because these vaccinations and the antiviral drugs are so important to this human society now, so that we really have to focus and just invest much to prevent this crisis, which is coming soon in the nature. So in the final slide, I'd like to emphasize that the basic science is a safeguard for humanity and society, And especially this is important in the age of uncertainty and the crisis. So this fourth industrial revolution and this, the viruses and climate change is that have already emerged as a new threat to and opportunity to scientists and whole human being. So relying on existing knowledge alone has limitations in response to such challenges. So we need to really investigate more on the fundamental principles of nature, and then we have to find the solutions, and we have to communicate with the people, and we have to form this sustainable development. Okay, thank you again for your participation, and thank you for listening to my presentation. Thank you.
So President No, thank you so much for sharing how IBS is handling COVID-19 and pandemics we might encounter in the future. So we have heard from all of our speakers, and now let's get into the panel discussion. Just reminding you that today our summit is taking place under the theme, The Role and Responsibility of Basic Science Institutes During and After the Pandemic. So here's our first topic, Impact of COVID-19 on Research. Our lives have changed dramatically ever since the COVID-19 outbreak, and restrictions on mobility had a huge impact in terms of research productivity. So I would like to direct my very first question to President Petty. President Petty, what measures can institutes take to ensure continuity of research and excellence during the pandemic, and what has the crisis taught us for future planning?
Yes, thank you. Thank you very much for this very interesting question. First of all, the situation in France was not exactly the same that the one described in Korea, and we had to close our labs for 2 months in March and April 2020. And it was really, really a pity, and this had many consequences. Not on all sciences. I have to say that at the very beginning, we had even some colleagues who said, yes, fantastic, the labs will be closed, so I will have time to write my papers. But for all experimental sciences, it was a drama. And unfortunately, it was the only period when we had to close the labs. And after that, even if when the situation was less satisfactory in France, we didn't close our labs anymore. So probably the first lesson that we learned from the crisis is that to close the lab is a drama, and we have to do as we can to avoid to go to this issue. That's the first point. The second point is, and we probably all share that, is to see that video conference and virtual meetings are possible, clearly, but they have their limits. They are possible. It's not so complicated to work together if you know people, and probably some long flights are not always necessary. Even if in particular, when you have to share the Atlantic for half a day meeting is probably not necessary. But also, I think that these tools have also shown their limits. And as Professor Stratman said, in particular for the young scientists, it was complicated to build relations when you don't know people and when you see only by screen. So I think that's probably the second lesson, is that we face-to-face meetings are absolutely necessary. And perhaps the third lesson, and I already mentioned it very briefly, is to see that how interdisciplinary is important. And the crisis has shown that clearly to face a crisis like COVID-19, as I said briefly before, you need, of course, biology and chemistry, but you need also mathematics and data sciences, and also humanities and social sciences. We all face in our countries some non-rational reactions of part of the people who refuse to be vaccinated, even if all shows and proves that it is less dangerous to be vaccinated than to not be vaccinated. Sometimes people are not rational, and we cannot blame it. We have to take this into account, and that's why humanities and social sciences are important. But it's also why interactions between basic sciences I mean by that mathematics, biology, chemistry, and humanities and social sciences interaction are so important. So that's probably the three main lessons that I consider we have learned from this crisis.
Thank you so much for sharing your 3 lessons from the crisis. And during the pandemic, various needs and public expectations arise for top research institutes. Some may ask for scientific guidance, but sometimes they ask for quick solutions. So I would like to next ask President Stratman. So throughout the pandemic, what public expectations did you see from Germany, from the public, and how did your institute continue to thrive? And what was also your biggest lesson?
Yeah, I think, first of all, I think the majority of the public in Germany, I would guess 80% or so, has shown that they trust science. They had very high hopes in science, and we have been successful, at least with one German company, to provide vaccines, let me say, for all over the world based on this mRNA technique, which is a revolution in vaccine development. I think we had a reasonably good health system in Germany, so for that reason, we never have closed our institutes. We always have been operating them on the basis that 50%, they had a kind of 50% presence mode in general. I think we have seen in Germany in general systematic weaknesses in certain aspects, in particular in digitalization of schools and universities. I think there was a kind of crisis mode. We had to operate our institutions in Germany, and we have seen that in particular schools were not adequately equipped, let me say, in order to deal with a kind of remote operation mode. That wasn't true for the Max Planck Society. We could do so, but in general, schools were not on that level. What I found very remarkable as a European, I have to say, that Europe as a whole did not fall apart. Europe as a whole was really putting all the effort together to come up, let me say, with a solution for this special crisis. And you have to know that the vaccines in Europe have been distributed by Europe and not have been distributed by the individual states. So all of our states in Europe, from Poland to Germany to France, got an adequate share of the vaccines, even in times when this was difficult to handle. So I think Europe has really shown remarkable. And at the same time, our biggest, for the state as such, the biggest threat is of course an economic threat. That industry went down to a large extent. For example, industry like the airports and the whole like Lufthansa, the flight companies. And again, I think Europe as such has come up with a huge financial aid package, let me say, to help those individual companies to survive. So I think in general, what I found very positive is that Europe as such gained trust. Now, for the Max Planck Society, the lessons learned, besides the topics which have been mentioned before, we also had to learn that you have to come up with supply chains which operate adequately. For example, we operate huge animal houses. These animal houses need, for example, special food many times. You have to make sure that even in a pandemic, this supply chain does not break down, because then suddenly you lose many of the assets we have in our society. Fortunately enough, I think that was true, but you all know that we have a shortage in masks, etc., in March and April last year. So I think to make sure that the supply chain even is ongoing in terms of a crisis, I think was, to me, one of the biggest lessons I learned. The second lesson I learned, at least in Germany, is that the idea to run all our institutes on a kind of top-down mode, that is not successful. I think we have been quite successful in the Max Planck Society to make sure that it's a bottom-up mode of operation. So all of our institutes had to solve their problems with some guidance, of course, from the central unit of the Max Planck Society, but they had to solve their problems, let me say, on their local basis. And it was very, very positive. It was very flexible. They could adequately react on the individual boundary conditions given to them, let me say, in Munich, Berlin, or wherever this has been. The biggest challenge I can see is that a minority of people do not trust science. As I mentioned before, they do not want to get vaccinated by themselves, which puts a threat, let me say, on all of us, because that means that the pandemic cannot be, we cannot deal with this pandemic in an adequate manner. So that's more or less my conclusion for Germany and the Max Planck Society.
So thank you, President, for sharing your experience. So now let's turn to Korea. So we heard about the new research center, the Korea Virus Research Institute. So I would like to ask President No, this institute is pretty new and there's a lot of work to be done. So what kind of support would you like to give to this institute? And also, what do you expect, what kind of position or the role this institute will play in the global world?
All right. This institute, this Korea Basic Virus Research Institute, was set up such that it can perform this, studies on the basic nature of the viruses and how it can get impacted and how people get immunized on these viruses. When this pandemic came, we suddenly in Korea we realized that there is no research unit which really have capability, or there is no group of people who can study the basic nature of these viruses. And that was the problem, and that's why we set up this research institute in such a short time without preparing too much. And this is the first top-down like a strategic research unit at IBS. All the centers at IBS, we select people and they propose and their research topic, and we supported it. But this is completely different. And so that we know that this timing is very important, so that as a president of this IBS, I want really jumpstart this research institute. So we want to provide this research environment, educate for basic research for the viruses. So that, of course, the funding is very important, but also we want to provide all the equipment, and we want to share current existing IBS facilities, such as animal facilities and supercomputing power, and also this we have this cryo-EM facilities, and all these will be dedicated to this Virus Research Institute. And we are now building up new spaces for long-term plan for this Virus Institute. So most important fact is that in Korea we need to have this research capability for coming these new viruses. And we expect that this Virus Research Institute play a role of the research hub in Korea, so that it can have a consortium with universities, research institute, and also domestically and internationally, so that this institute, we expect them to provide the basic scientific fact on viruses, so that they provide the clues to the people how we prepare and react to this coming crisis.
Okay, thank you so much, President. No, it really resonates with what you just said about this is just a training session. We might encounter more in the future. Okay, so let's move on to our next topic. We have a total of 4 topics for our panel discussion today. Our second topic is addressing pseudoscience. I think you've already heard many examples about this. So let me start with Executive Director Koyasu. It was really interesting as a computer scientist to hear about the use of supercomputer Fudaku in the drug discovery for COVID-19. I believe it is also equally important for researchers to be able to communicate the outcomes correctly with the public. So how can we help scientists whom we are not always really good at communicating, to the public? How can we help scientists effectively communicate? If you have good examples at RIKEN, could you please share?
Well, thank you very much. It is indeed difficult for most of the scientists to communicate with people in lay language. So therefore, we have to help them to effectively communicate their scientific outcome to the public. So for example, one thing we tried was to set up some YouTube channels to explain what the coronaviruses are to the general public. So for example, I can share some of the example. So this is what we did. We made for the children. So what is the new type of coronaviruses that is much thinner than the hair and so on? Like we can show how the coronavirus is named and so on. So this was the for kids. But then we actually make different types of YouTubes to show our outcome, for example. So this is the to explain the new type of vaccine using those cartoons and so on and so on. So in this particular experiment, what we did was to make vaccine that induces IgM antibody. Usually, we try to generate the IgG antibody, which is more effective. But for the coronaviruses, as dengue virus, sometimes the IgG antibody actually enhances the pathogenesis. So therefore, it might be useful to make the IgM-oriented vaccine. Fortunately, we now know that IgG antibodies induced by current vaccine doesn't do anything bad. But at the beginning, we didn't know about that. Therefore, we started developing the IgM-oriented vaccine, which was actually broadcasted through this YouTube channel. So therefore, we tried to communicate, send out a message through YouTube channel, for example. And also, we discussed the pseudoscience and an anti-vaccination movement. So by chance, I'm actually an immunologist. So and I'm a president of Japanese Society for Immunology currently. So therefore, we actually made a couple of the YouTube videos to explain what vaccines are and how vaccines protect our body from the viral infection. And so this kind of effort seems to be important under this kind of situation. Thank you very much.
Thank you so much. Okay, so let me turn back to Korea again. IBS has launched various initiatives to fight against the fake news on COVID-19. So President No, could you explain about some of these initiatives and could you assess their impact?
Right. During the first few months of pandemic spread last year, there was a lot of rumors in Korea and probably over the world. And really, it's an unimaginable rumors are spreading out. to the general public, so that as you led this project, we started the so-called fact before rumors campaign, and we collected all this, the real fact all over the world, and we prepared infographics so that people can use to prevent the spread of the false news and leading to crazy activity by the people. Also, as I mentioned during my presentation, we decided to publish a book which is really written by the scientists in front instead of book authors, so that people can really get scientific fact from the scientist. And also, most important part is their genuine opinions from their scientific career. They have their instinct, and they have their expectations on unknown fact. So we want to share their scientific opinion and the fact with the public. So that's why we decided to publish this book series on coronavirus, and it was very successful. And I think it is one of the most important contribution for IBS to the public on this in regard to the COVID-19. And of course, in the future, we will contribute by providing more basic science knowledge to the public and to the scientists in the world.
Okay, thank you so much. So let me turn to President Petty. CNRS News, the online website at CNRS, has published also a series of articles that give detailed information and scientific insights about the novel disease. As my research uses AI algorithm to debunk any misinformation, it was really impressive to see scientists actively debunking misinformation. So President Petty, could you tell us more about how the public in France responded to these efforts by scientists?
Yes, I think that, and Professor Stratman said it already for Germany, I think that the majority of people do not, in fact, believe in fake news and fake sciences. And clearly, what has changed, probably, if we compare with some years ago, is the fact that if you consider, for instance, that the Earth is flat, before you could find some people, isolated people. Now they can group together and make more noise, if I can say. But in fact, I am not sure that the number of these people has really increased. So what I wanted to say by that is that we have to pay attention to these people who are dangerous, but nevertheless, they are still a minority, and I think by chance. And so probably we have to pay more attention to people who in fact don't know and who want to be convinced than the one who are lost, I think, for science. And I think that what is very important is to explain what is the way we as scientists, we think and we act. I mean by that none of us, or I mean none of the citizens can transform himself or herself in a scientist in some weeks. Nevertheless, he or she can understand what does it mean to have a science way of thinking, a scientist way of thinking, which means what does it mean to verify some informations, to understand what kind of reasonings we do. And that's, from my point of view, very important to explain what are hypotheses, what are probability, what are reasonings, and this the scientific reasoning is for me a key issue. What I mean by that is that I think that we have to be more pedagogical, and we have to repeat and repeat. and clearly that's the key point. And we don't, as I said in my very first introduction, we do not have to decide in place of politicians. We just have to advise. I think that for citizens, in fact, it's more or less the same. I mean by that we do not have to understand for citizens. We have to explain and to give them all the materials in order for them to convince themselves. And after that, they can think what they want. But it's very important from my point of view, if we want to keep science at the right place in society, is that people do not have to think that scientists will explain to them what to think on in what to believe. We just have to explain what is science. Science is universal, and that's very important. Even countries which do not act against, for instance, climate change, these countries do not have their own scientists who say that climate change is not an issue. And so it's very important to explain to people that science is universal, and the meeting that we have all together today shows clearly how universal is science. And so we have to explain that science is universal, that the scientists' reasoning can be understood, and that people that can check and a certain number of facts or figures of numbers, even if none of them is really a scientist. So it means that we have to spend time to explain why science is not belief in some sense.
Okay, thank you very much. I think it's a really important message to learn that scientists' job is different from politicians' job, and we should really enhance our education for scientific thinking for the general public. Okay, so let's move on to our third panel topic, which is a new way of collaboration. So as a researcher myself, international and interdisciplinary collaboration is really critical. And due to restrictions on travel, we had to rely on online tools for the past 2 years. But now I see more conferences are opening up and they are welcoming offline participants. So I would like to ask Executive Director Koyasu. So RIKEN, it seems like RIKEN is actively collaborating with domestic institutions on COVID-19 research. Could you tell us more about this collaboration? And do you also see this kind of drug discovery expanding with international collaboration?
Yes, thank you very much. And as you said, almost all the travels were blocked for the last couple of years. So therefore, it's been really difficult to physically collaborate with people abroad. However, by using this type of remote conferences, we were able to exchange our ideas and information. And so that was really helpful. But domestically, it is also true that we haven't really traveled even within Japan. So we communicated through remote tools. But actually, for RIKEN, one of the most important collaboration was the collaboration with hospitals and medical schools, because we do not have hospital at RIKEN. So therefore, but we have a lot of large infrastructure and some new tools. So therefore, for example, I can give you one example. The researchers at University Hospital isolated B lymphocyte, which is reactive with coronavirus spike protein, and isolated the antibody. So we helped them to generate recombinant antibody for the therapeutics, and we helped them to solve the structure by cryo-EM, and we calculated the molecular dynamics with Fugaku. So that kind of collaboration was quite fruitful, although we haven't really entered the real clinical trials yet. And also, as you're a computer scientist, you probably understand. So you don't really need to come to work with computer, but you can remotely access to the computer facility. So therefore, we let the university people to use Fugak computer. After discussion with the ministry, we chose several subjects, and then let the university people to use the Fugak group to perform the molecular dynamics with the drug candidate and so on. So that was what we've done so far. Thank you.
Okay, thank you. It seems like there has been really nice collaboration with also open data and open resource, which is really amazing. So next, I would like to ask President Strickman. You've mentioned about social challenges that COVID-19 bring, and it's so true that we also hear that COVID-19 really gave us a chance to look back on our society, and a lot of people are now increasingly interested in social issues like climate change, food security, and inequality. So as a president of a top research institute, what new research areas are you interested in, and do you see the future?
Yeah, thank you very much for this question, which is a really difficult one, because it's very hard to look into the future and to give you some idea what the future will bring in science. And honestly, I think the topic you're asking me is a little bit what I would call the mission-driven research, which is very, very, let me say, active and which is pursued in many countries these days. Mission-based research means that you have some certain problem, let me say climate change, health issues, etc., and you take that as a mission and you want to focus science on solving these problems. Honestly, the Max Planck Society, I have to admit, is different in this. We are totally different in this. We never work according to missions. We work only with people. I think the idea we have is to get great minds all over the world, bring them into the Max Planck Society, and let them do whatever they want to do. So we give them really a package. They have 30 years on research on their own, and they define on themselves what they are interested in and what is not that much of interest for them. And honestly, doing so, many times you are ahead of the time, because you look in great minds and they form the future. They define what the future will bring. And only one example, one recent example, you know, we received the Nobel Prize these days for Mr. Hasselmann on his work on climate change. And that dates back to the 80s, more or less. His models are from the 80s. And that tells me in the 80s, you know, that was just the very beginning, the very, very beginning of discussions on climate change. And at that time, we had people in our society which were extremely in these fields and let me say, put together, let me say, the math and the theory to show, let me say, what climate change really is all about. And I could give you many other examples. One other example is Svante Pääbo, who is a prominent scientist in the Max Planck Society, who has defined the whole field on himself. We call it paleogenetics, which is now spreading all over the world. And again, he has been working on this topic for more or less 20, 30 years. So what I'm saying is, I think we should in science not try to look in missions and to look ahead of the time. We should be interested in people. I think the top-down view on topics ends always with the same topics everybody knows about. This trivial, the topics we are mentioning. And you do not know what the topics of the next 20 years will be. So the question to me is not, what is the topic of today, but what is the topic in 20 years from now on will be the hot topic. And I guess that none of us will be able to answer that question in detail. We have to look for those people who define the future. And so I have to say, we have to think very careful about this mission-driven mode of science, because in the end it may also prove to be a waste, because too many people focus on the same issue and you miss, let me say, the novel ideas, which in the end makes real breakthrough. And by the way, if you look at the vaccination, if you look at the COVID vaccination, this mRNA business, and we'll see who will get the Nobel Prize in the years to come, you will also see that dates back 20, 30 years. There have been very fundamental work on how to modify mRNA so that the body takes it. If your body cannot take the mRNA, it doesn't work. And that is going back many, 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 many years as very basic science. And if this work wouldn't have been done 20, 30 years ago, we wouldn't have the vaccines today. So if people think that if you have a problem and then you ask the scientists to solve the problem, then that solution only comes back, is based on knowledge which more or less is knowledge which is already there and did exist and has been in existence for decades. So my conclusion is, I think science does not change that much. It's now much more interdisciplinary than it used to be, but it's still based on minds of highly capable people. And so for that reason, I think also Max Planck Society will not change its operation mode. I think we still look out for those people which we think are the ones who define the future. We'll see if that is true. And I think that is an alternative view from this mode of mission-driven science, which is very popular in many states right away.
Thank you so much for your remark. So rather than looking for them starting from the mission, so find the people who perhaps have defined the future and have perhaps good mission. And I'm proud to hear that because I'm an alum of Max Planck, as I spent my postdoc years at Max Planck Institute. Okay, so let us move on to our final topic, which is vision for basic science institutes. So this month, IBS is marking its 10th year in its journey, and I would like to hear more about the long-lasting vision from all of our panelists. So let me start with Executive Director Koyasu. So RIKEN has been around for over 100 years, and it has earned the trust of the Japanese people throughout the course of its long history. As the Executive Director, what advice could you share to IBS in strengthening the trust of the Korean scientific community and the general public?
Okay, thank you very much for the question. As I said in my last slide, I think the important thing is a prompt dissemination of accurate and comprehensive information to the public in lay language. This is one of the important points. And also, as Professor Stratman said, we have excellent scientists within RIKEN as well. So we value their ideas and their own ideas and then their research. So sometime later, those research outcome will be picked up many other people, and then we will get a real fruit which we can send back to the society. So therefore, it is important to support excellent scientists within the institute. And also, we as executive directors can play an important role between, in our case, the government and the institute to share the information. And sometimes we can communicate with a certain group of scientists within RIKEN to form certain team to tackle certain problems based on their ideas. But we can actually support the teaming of those scientists. So, and also it is important to have a good relationship with the people, scientists in the university, because there are many different disciplines and fields which we cannot cover by ourselves. So therefore, to communicate and to collaborate with university scientists seems to be very important for institute like RIKEN. Thank you.
Thank you so much. So let me come back again to President Stratman. Max Planck Society also has a long history of conducting basic science in Germany. And how has the role and responsibility of Max Planck Society changed since its establishment?
Well, I think we have now more or less 100 years of history of Max Planck Society and our predecessor, the Kaiser Wilhelm Society. In the beginning, the society was much more applied than it is today. The reason was simply that a large part of the funding came in the early days from industry. Nowadays, it's pure basic science, and I think, as I mentioned before, the vision is we have to stay true to our principles. We should think in people and not in programs. And I would like to add an element which I think is also very necessary. The science we do, or the outcome of the science, is not just knowledge. That's one major part, of course, of what we do. But the second part is science is a major part of the higher education. So we train massive amount of people in our countries. That's true for France and Korea and Japan and Germany. We train massive amount of people, let me say, to think in scientific terms. And what does that mean? Think in scientific terms means you have to think. You have to think by yourself. You just should not follow, let me say, what is said to you. You have to question sometimes what is on the table because it might not be true. You have to look for truth. You have to understand. Science is not opinions or beliefs. Scientific findings are valid and reproducible facts. And that's also true for industry. If you work in the industry as a, let me say, trained as a trained scientist, a formally trained scientist, even Angela Merkel is a formally trained scientist. You see how she operates in terms of the COVID crisis, and she operates differently than many others because she has a scientific knowledge, she has a scientific background, she does understand what it means to have an exponential growth. And it's these simple things you have to understand in order to be capable also to act, let me say, in many other fields in public life. So what I'm just saying is we have to understand that science is not just findings, it's just not just publications, it's not just knowledge which is spread all over the world. It shapes also our countries. And the more of our leading people in industry, in politics, in parliaments, or whatsoever, have undergone some kind of science training, the more you will see it is also positive for the country because they can distinguish them between facts and just beliefs. And so for that reason, I think we have a much, much larger impact than just the papers we produce.
Thank you so much for your response. And President Petit, as the president of CNRS, one of the largest contributors of top scientific outcomes to the world, what advice could you give to IBS for the next 10 years?
Thanks again for this question, for the invitation. I think, in fact, what is interesting from this discussion is that I think that we more or less share the same ideas. The fact that we have to explain why basic research is so important for society. And as Professor Stratman just said, science is not important only for knowledge. Science is important for politicians, science is important for industry. And I think that a center like IBS has, in fact, the chance to be in a country, Korea, which, at least from my point of view in France, Korea believes in science, and it is clearly illustrated by the amount of investments devoted to research in Korea. And I have to say that sometimes I'm even a bit jealous if I compare the situation between France and Korea. And so you have this chance, but it also means that you have also to be at the right level. I mean by that I assume that your country expects a lot from IBS, and now in finally a small number of years you have reached an international level of high quality. Due to the quality of your scientists, and once again, I would like to insist on the fact that to invest on science is also mainly to invest on people. Science is done by people, and so you have to educate your students. You have also to attract probably researchers from all over the world, like we do in our institution, because science is international. And so it's just 2 words. I think that you have to keep your relations with an institution like the institution represented today, but also other top level international institutions, you do not have to change, I think, your main goal, which is to do basic science, and it's indicated in the title of IBS, and that's very important. And basic sciences, fundamental sciences, is absolutely crucial for society. And so don't change anything, if I can say. Just continue what you marvelously did for now 20 years. And we will be very happy, at least at CNRS, but I am sure that my colleagues share this opinion. We'll be very happy to continue to collaborate with you in the next 10 or 20 years.
Thank you very much. So this naturally leads to the question to President No. So it must be really exciting and also challenging to lead IBS at its 10th year. So what is your vision for the next 10 years?
Right. Today I was really impressed by the comment from the president and director from the world-renowned institute. You guys are commonly emphasizing people. And actually, when we start IBS, we benchmarked CNRS, Max Planck Society, and RICAN. And I think that was our great decision to benchmark these three institutes. And I can see even today's conversation, your advices from your long history and emphasizing people and long investment. That was very impressive. IBS is just 10 years old, and we are expecting 10 years anniversary. And we think that IBS made really rapid growth, and then we achieved our so-called goal of a decade of new discovery. But still, IBS is in the infant stage as compared to this world-leading institute. So that for the next 10 years, I want IBS to lead the new discoveries in basic science. So that is how I see IBS in 10 years from now. And also IBS to become a flagship institute in Korea, research institute, especially in basic science. And also I want to make IBS as one of the world leading institutes. So we want to join this club of these three institutes in 10 years coming. Although then we will have only 20 years of history, we want just to, if you allow us, we will join 100 years, institute with 100 years history. So to achieve that, first, we, as all the directors, president said, we also want to emphasize on people, especially early career people at that stage, because as we got heard today that basic science need long investment and it need a very long time for the growth, and we don't know what will impact which area. So that starting with the early career scientist, that it will be a very good way of doing it. And also, I really wanted to ask Riken, saying that we want to also have a large infrastructure, like your Spring 8 synchrotrons, and we are building up a heavy ion accelerator. It's get delayed, but we will have some really fantastic basic large-scale facilities. So we want to also maintain and then use that. So that we probably have to learn from Rukan how to operate that as an institute. Also, we have a problem with seemingly as a research institute, how to incorporate these university professors in IBS frame. So probably I have to learn from Max Planck Institute, how do you collaborate with the universities nearby and how to take people from the universities to the institute and send people from institute to university. And those, I think, is still, we are on the learning curve. And the Korean situation is rather different. And as a scientist to do research, but the politicians make decisions. Even for the science operation, they tend to make decisions, which is very different from Japan or from Germany or France. So that we have another additional difficulties for that. But I want to assure that we will do our best to become one of them. So that's my vision for the next 10 years of IBS.
Thank you so much for sharing your vision. It's exciting to be on the same rocket ship. So now let's move on to the Q&A session. So we will first get questions from the floor, our offline audience, and then we'll go through maybe 1 or 2 questions from YouTube and Zoom. So if any of our offline audience here on the floor has a question, please raise your hand and we will bring a microphone to you.
Thank you. My question is directed to Max Planck Society President Martin Stratmann. You had mentioned a number of directors and researchers are from different countries. And I live in South Korea, and the international population is about 5%. As IBS or other groups work to try to attract and keep international researchers, what kind of thoughts or recommendations would you have for that process?
Yeah, that is indeed a very important question. As I mentioned before, we even hired 2/3 of our directors, more or less from 3 countries, US, Switzerland, and Britain. I think and in the end, if you want to be successful, you have to be attractive for those people, not only living in your country, but also for people living from all over the world. I think the real issue is that, of course, you not only have to be attractive for the person you want to hire for your organization, but the whole family will move. So the living conditions of the family is essential. I think this is the clue. I can tell you from the many discussions I have with upcoming directors which join the Max Planck Society, it's always a point, what about my wife, my husband, my kids? What about international schools? What about the living conditions in your country? And I think we have to understand that in the end, we can only be successful if the cities we live in, the boundary conditions we live in, are attractive for international people. I think that is most important, and I know that is different. That poses difficulties for some countries. I'm fully aware of this, but that is the most important issue. And for Germany, I have to say, over the last 20 years, that has changed dramatically. We have many of these small university cities, like Göttingen or Heidelberg, so which are small cities where people really love to live in. And at the moment, I rarely had a discussion where I could see that the family was just not willing to move to Germany because Germany is so ugly or so. So I think you have to really work on the living conditions for the whole family. That is most important. Otherwise, you will fail to attract those people you want to attract. And that is not only a question of the organization, but it's a question of the city. It's a question of the whole surrounding we live in.
Thank you so much for your response. So do we have another question from the floor? Okay, while people are thinking, we can also look into the questions from maybe Zoom and YouTube. Okay, so having the privilege of a moderator, I would like to ask one question. So My field is in AI and deep learning. And how do you all perceive the use of the new techniques like artificial intelligence and algorithms in basic science? So, yes. Please go ahead.
Okay, just two remarks on that. First of all, I spoke previously of the RNA discovery from the beginning of the very 60s. Concerning the deep learnings, I would like to recall the fact that the algorithms, the first algorithms of the deep learnings are 30 years old. And look, it's not so new. So we also have to recall people that even if in AI and deep learning techniques, things that do not come from yesterday. What is fascinating me with AI is the impact of AI in all sciences. We all know that AI impacts our daily life. But it's, in fact, more new to see how AI impacts sciences. And the impact sciences not only by improving existing techniques or accelerating existing techniques, but the use of AI really lead to new techniques. It's true in chemistry, and Professor Statman is much more specialist than I am to explain that, but it's also true in astronomy, and it's also true in basic science, in humanities and social sciences. And I really, we think, you asked the question, what will be IBS in the next 10 years after the first 10 years? And I think that probably the impact of AI on sciences will really will lead to major discoveries and major new techniques. And this obliges probably us as institutions to think how we organize interactions and cooperations between people from data sciences, computer scientists, mathematicians, and people from other fields of science. Just a few remarks.
Thank you very much, President.
May I just add one additional comment to this? I think I fully agree with what Antoine has said. And I think in addition, we also have to think in ethics of AI.
Oh, yeah.
I think it's very important because the ethics issue is an issue. We all know that AI has many, many positive outcomes, but you also know it can be misused, and it can also be terribly misused if it's in the wrong hands, I have to say. And I think to have and we are working on this in the Max Planck Society, but I think in also other organizations, we have to come up with a statement on how we see ethics in AI and what we do want to support and where we see limits in using AI. I think that's also an issue in order to make sure that the public understands what we do.
Thank you.
May I add one comment?
Sure, please go ahead.
So I think the deep learning, machine learning, and AI actually changes the relationship between hypothesis and data. So in modern science, we sort of have hypothesis, and then in order to prove or test the hypothesis, we perform the experiment to obtain data. But now you have a lot of data, and the data sciences, with a combination of data sciences and AI, now gives us a new hypothesis to be tested. So that kind of relationship is gradually changing the style of science. I think that is another important issue. Thank you.
Thank you so much. President No, do you also want to add something?
I think it is AI and machine learning will provide a new tool for the basic science, but I think also it provides chance to give a new basic science area as well. So there are many things which we couldn't do before, but now we have a capability of handling this massive data. Now we can do a lot more. So I think I'm in the field of synchrotron X-rays, and as we develop this, free electron lasers, and we got a lot of data coming in, and previously that we couldn't do anything with that because the data was so massive. Now, if we include AI and machine learning, then we have a tool to look at the data very fast, so that those will provide a new opportunity to do new science.
Thank you so much. So I think a lot of the ideas today resonated across the institutes. For example, the open research, open ideas, new domains, new tools, and we should, not define just the mission, but look for the good people who perhaps define the future. So this has been a really inspiring summit, and thank you all for your excellent presentations, insightful remarks. On behalf of IBS members, I would like to extend our sincere gratitude to all of our panelists, President Martin Strautman, President Antoine Petit, and Executive Director Shigeo Koyasu. Thank you so much for joining us today. And President No Do-young, thank you for hosting this event.
Thank you.
And also a big thank you to the audience on the floor and also online for taking part in this summit. So this concludes the IBS Global Summit. I am Mi-young Cha from IBS, and it was my true honor to be your moderator today. So thank you so much. Good afternoon and good night.
Thank you very much. And congratulations again.
Yeah.